Hello, everybody. Let's have a revision of our discrete math midterm questions. We had 20 questions, each worth 5 points, and I would rather see them in the question bank because they would be ordered by the objectives than to go and have an attempt where they would be shuffled. So everyone might have had an order different from this one in class, but here at least we have them showing the objective that they cover. They might not be ordered exactly how we want them, but at least into blocks. So, because I can see 1.1, 1.2, 1.3, and then 1.6, but let's go for it. So this question says, recall that Q is the set of all rational numbers. This would be the last time for me to remind of this. So if the question comes later in the final, just you have to know the names by now. Let me refresh your memory quickly. So I would say we have Z, this kind of Z for integers from a German word, Zollern. And we have Q for rational numbers, opposed by Q prime for irrational numbers. We have R for all real numbers. We have I, you can say N for natural numbers. So from now on, you will consider that we need to know these, but for this midterm purpose, I just gave the reminder, okay? So recall that Q is the set of all rational numbers. Now, its definition would be any number N over any number M belongs to Q if N and M are both rational and M is not imaginary. This would not be correct except if M was just restricted to be not 0, because 0 is a real number, it's not imaginary, and we can still fall into this mistake. Actually, it's interesting that if N and M are both rational numbers, then yes, N over M would be rational, but M's condition here is to be not 0. So here we have not 0, here we have not 0. We have to compare these two. Not 0 here says they are both integers. Here it says they are both irrational. This is incorrect. This is a correct answer. Just to pass by the other answers, let's see. Both integers and M is not real. No, M is not 0. And M is not 1. No. And also again, M is not greater than N. No. If that was M is not greater than N, so M is smaller than, it's the definition of an improper fraction, which we don't want to have right now. We just have to have this one. N and M are both integers and M is not 0. And we have it in the book. We have it also in the slides. Okay. So this is the correct answer. This is the square root of X, which would, what would we say about the square root of 18 and 81? Which one is the square root of 18 not a real number? It is a real number. It's not imaginary. Is it an irrational number or a rational number? It's irrational because there is no perfect square root, integer square root for this number. But here we would say it's rational because there is a square root of 81, which is 9. Now, W plus X plus Y plus Z, is it equivalent to anything with a minus? Never. Or not easily. It can be, but I didn't put any one of these with a minus, except if you have minus minus, it would make it a plus. Here we have minus minus, but it will not make this Y plus. So all of these have a minus result, while this one is clearly the answer. It's just the same thing as here with an extra parenthesis that is not even necessary. Now this one is more tricky. We know that if you have minus 1 here multiplied by this parenthesis, it will affect both y and z because of the distribution property, and it will make this y negative and this z positive. But anyways, the question was easier than theirs because it again just left them here as they were and grouped these two, which will not affect the answer, obviously, because anyways they would be grouped by precedence expressions. But let's have a look at other answers as well. Would this one work? No, actually, because this minus would make this sign become a plus, and here again no, because we are having this minus to affect the y, and here it's positive. How I would look at this, we would say w plus x minus the result of subtraction y minus z. So minus something little. This is not necessarily minus something little because it's minus z. This is more like it, except that this minus is not having the parenthesis. This is again the correct answer. The associative and the commutative properties. Commutative is this an example of it? It's a wrong example. It cannot be an example of it because it's even not correct mathematically for real numbers. This one is correct for commutative, and this one is correct for associative, where you can say a plus b plus c is equal to a plus the addition of b plus c, or it's also equal to the addition of a plus b all added to c, or with c added to them. Which of the following can be a discrete set of objects? Cars, body temperatures, car speeds. Remember when we spoke about continuous versus discrete values, or continuous versus discrete amounts? Individuals that cannot be divided are like cars or people. These are considered discrete objects. Body temperatures are continuous. You can find any temperature between temperature 99 and temperature 100. There is 99.5. There is 99.00001, etc. The same can go for car speeds. Between 100 and 120, you don't only have 105, 110, 115. You also have 101, 100.5, etc. Discrete math has its major application in digital systems like computer science. Not calculus. Calculus is more about continuous, not physics. Physics is more about continuous as well. Choose all that applies. The set of integers z, and as I said, do expect in the finals to have something without me reminding you what the z, q, q prime are. It's a subset. It's a proper subset actually of. Is it a subset of all rational numbers? Yes. Any m over n, any z integer can be m over n. Just put it over 1, for example. Is it an irrational number? No. Is it a real number? Yes. The whole box of all of these numbers is called real numbers. Is it a subset of natural numbers? No. Natural numbers is a subset of integers, where natural. If we were to define our own set of all integers which accept division by 2, we want this set of all integers that accept division by 2. Which of the following would be the most comprehensive roster definition? 246, 0246, or even these, -4, -2, 0246. This one is most comprehensive. To simplify a fraction a over b, it's to its simplest form, we must multiply both the numerator and denominator by the GCD of a and b, multiply both the numerator and denominator by the LCM, which is least common multiple, or divide both by their GCD, or divide both by their LMC. Let's take an example. If I want to say 7 over 14, this is obviously not the simplest form, and the simplest form might be half, 1 over 2. We divided both by 7. What is 7 in this case? Is it a multiple common to 14 and 7, or is it a divisor common to 7 and 14? It's a divisor. And in this opportunity, I would take the opportunity to remind of a video that I had recorded on Moodle, and it's extremely important, this one, for these questions.
Hi, everybody.
We spoke about,
let's talk about greatest common divisor.
GCD and LCM.
Well, dividing each time by time, saying it's equal to 6 divided by 8, it's equal to 3 divided by 4, until we reach the result.
Okay. So that was our question here. The answer is to divide both the numerator and denominator by the GCD. (13) or any base to the power x multiplied by the same base to another power y is equivalent to the same base raised to the power of the addition or summation of x and y. So this is the correct answer. We've given these rules many times right now. And here is just another example of it. So the answer will be over 8,000, 3 to the 8,000. It's an application, because the objective says that you need to know how to evaluate these and have some application with them. Adding and subtracting fractions. This is a simple addition of two fractions. If we want to go in our way, we would say the least common multiple of these two numbers should be computed as follows. 16 is nothing except for, excuse me, it's nothing but 2 by 2 by 2 by 2. And 12 is nothing but 2 by 2 by 3. The GCD, the least common multiple of these two numbers would be got after we get that the denominator of the first one is 2 to the fourth, and the second one is 2 to the second multiplied by 3. So we would take the maximum of these two exponents, 2 to the fourth, which is 16, and we would take the maximum of 3 to the first and non-3, which is 3 to the 0. So it will become 16 multiplied by 3, which is 48. So these have to be over 48 eventually, both of them. Now the first one was multiplied by 3 to become 48, so it's a 9. The second one was multiplied by 4 to become a 48, so it's a 20 here. And this is one of the answers directly, but here it says you have to choose all answers that apply. So we would see if there are others that would apply. To do that, we would sum these, and it's 29 over 48. We can see that 29 is a prime number and 48 is not a multiple of it, so we cannot simplify it further. So is there 29 over 84? No, but still this answer is correct. How would we know? Because this one, this one, this one, and this one all need to be simplified before we take our full decision to know if we do have something equivalent to 29 over 48 or not. So it's from, you can never compare and know if two numbers are equal to each other or not, if they are not two fractions, I mean, if they are not both in the simplest form. Let me choose this pen. So we are looking for, and another color, we should be looking for 29 over 48. Is this 29 over 48? It is apparently not, but we have to say divided by 2, divided by 2, it's a 14, divided by 2 again and again, it should be 2 over 7, and the answer is no. Is this 29 over 48? Divide by 3, here it's a 5, here it's a 14. No, 16. 5 divided by 16, no, it's not exactly this one. 8 over 48 divided by 8, it's 1, divided by 8, it's 6. Again, no. This one was chosen. Now here, it's tricky. We can divide by 2, so we will have 5, 8, and here we will have 9, 6. Still, divide by 2. We will have 29, and here we will have 48, which is exactly what we are looking for. Okay? So this one also applies. So this was a big question. This was a big question where you need to just make sure that you are comparing equivalence correctly by taking all to their simplest form after adding and subtracting. Okay, so these are the correct answers. And let's see the distributive property application. A multiplied by the sum of B plus C. In this case, multiplication will be distributed, and the answer will be A multiplied by B plus A multiplied by C. It will go to each one of the inside arguments or numbers. Fraction subtraction. Again, if you want to subtract A over B minus C over D, then it's best to unify the denominators over any multiple. We must use a multiple of B and D, and it's best to use the least. And since it's a multiple choice question, we don't have BD, which is a multiple of B and D, or any other multiple of B and D, like 10 BDs, and we only have GCDs and LCMs. We would choose from the LCMs because these are multiples, and specifically the one of B and D, not the one of A and B. So this is the answer. We use GCDs to simplify a fraction. We use LCMs to add or subtract fractions. GCD question. Let GCD of x and 2x denote the greatest common divisor of a whole number x and its double 2x. GCD of x and 2x would be, now remember, the GCD, greatest common divisor, can be only as great as the minimum of the two numbers. It can never go over the minimum. It's a divisor. It can be less than the minimum of the two numbers. Like, for example, 6 and 18, it would be 6. But if we say 6 and 14, it would be 2. But never we would say 6 and the number which is greater than 6, and then we will get the GCD also greater than 6. It cannot go. But even if you don't know this stuff, but you do know the concept of greatest common divisor, you know that you need a number that divides both x and 2x. One divides both, but it's not necessarily the greatest common divisor. 2x does not divide both. 2x squared does not divide both. X itself is the greatest divisor for x, and it's one of the divisors, the middle divisor of 2x. This is the answer. LCM. Similar question. Let LCM x to x denote the least common multiple of a whole number x and its double 2x. The least common multiple of x and its double would be, it's a multiple, so it cannot be x. It has to be at least 2x because you need it to be a multiple of both numbers, and 2x, the first multiple of 2x is 2x itself, and then you go for 4x, 6x, 8x, etc. And again, the least common multiple of these two would be 2x itself, because 2x for sure is a multiple of x. PEDMAS. Okay, w divided by x plus the result of y multiplied by z is equivalent to this thing? No, for sure not. In this thing, they are adding before dividing and multiplying. It's the quite opposite of PEDMAS precedence. So what about this one? Yeah, this one seems very good. What about this one? Again, they are adding before, forget about it. And besides, it's just the same as this one, except for the previous and last pattern brackets. So, and here it's another mistake. They are not multiplying until the very end, but they should multiply before they add. So here they are going strictly from left to right, but PEDMAS says that no, you don't go strictly from left to right whenever you have addition and multiplication. You start with multiplication. Division. X divided by y divided by a divided by b, or let's say x over y divided by a over b. We said whenever we have fraction division, we would just swap the numerator and denominator of this one upside down, so it will become, and make it a multiplication. It will become x over y multiplied by b over a. This is true. To multiply two fractions, we must first unify their denominators, false. To add and subtract, yes. To multiply, no. To divide, no. And that was the last question. Now let's have another good idea, just to look at the average of these grades for each of the questions. Each one is supposed to be from 5. We can see that most of them are 4 in this part of the view, but here we have 3.59 and another 3.13 in this question, 3.75. Otherwise, all are towards the very high end. No question had less than 3.13. So let us have a look at these questions. So the first question, or let's look at the special ones at least. Let's look at the first question. First question was here. Recall that Q, and the one that is saying that it's not 0, and we have 4 out of 5, which is good average. Now let's look at the 3 average questions. Yeah, this is one of them. Okay, excuse me, I'll open the answer of the student to make it easy. Sorry for that. The most comprehensive way of defining these would be from minus infinity to positive infinity. Another question. This one, again, sorry again. To subtract, you need to unify them over the least common multiple, because you want to multiply this number and this number so that they don't change. You multiply the numerator and denominator by a number so that they don't change, but in the same time you get a unified denominator for them so that you can easily add or subtract. I feel it's easy, but probably because I have some good background in using it for a long time. For students, maybe you need to look at Khan Academy or other resources if you still feel unsure about how to add or subtract fractions. And the last one, which has an average of 3, would be this one. And sorry again. It says if the GCD of two numbers denotes the greatest common divisor for a number and its double, then what is the greatest common divisor for x and 2x? It's x itself. Correct. This is a conceptual question. You can only answer it if you understand the concept. Okay, wish you best of luck. Still, I know that the grades in general in our course are high, very high compared to other courses. So let's just wish for the best until the end of the semester. Thank you again. Bye.